Good day, sir. I'm Marty Boss, and I'll be the one to present my PIT, which is the title the automatic sorting system using vision. So, so first question is who has have done the work? So it is the Saurin Mukund Set and Dr. Rahul Kerr. So what were their goals and objectives? So it is to design and build an automatic sorting system that uses color vision to sort objects. The system uses a camera to capture images of objects on the conveyor belt, and then a computer program analyzes the images to determine the color of each object. The system then uses a robotic arm to pick up the objects and place them in different bins according to their color. So what were the research questions, if any? So there are no any research questions based on the study. So what were the methods in terms of what that related to? So um, how have they gathered relevant data? So the system uses a proximity sensor to detect the process of the product on the conveyor belt. The sensor then sends the signal to the microcontroller, which sends a signal to the computer. The image processing software, which is the MATLAB of the system, then sends a signal to to the camera to capture the image. Once the image is captured, the software processes the image and then generates signals according to the requirement, which are then sent back to the microcontroller. The microcontroller then controls the conveyor belt and robotic arm. So the robotic arm picks and places the given component according to the color. If the color is not matched with the given requirement, the product is rejected. So how is the data gathering setup? So the conveyor belt, driven by a permanent magnet DC servo motor, facilitates the movement of products for inspection. Positioned above the conveyor belt, the web camera, which is the Intex IT305VC, captures images of the products connected to the computer by USB for seamless data transfer. A proximity sensor installed along the conveyor belt detects the presence of products and transmits signals to the Atmega 32 microcontroller. This microcontroller is strategically positioned to receive signals from the proximity sensor and interfaces with various components, including actuators such as stepper motors and servo motors using specific ports and communication protocols. The MAX32 IC facilitates communication between the computer and microcontroller through serial communication. The, compute, the computer runs MATLAB, equipped the image processing toolbox to analyze captured images, set threshold values for color detection, and make decisions regarding sorting. Um, so in this block diagram, so it shows that it starts from the camera, then it proceeds to the computer, which is the image processing, then it proceeds to the microcontroller. So the sensor, which is the input, which sends the data to the microcontroller, then the microcontroller processes, and the conveyor belt, the robot, and the robot, which is the output. So what are the tools, techniques used in the data gathering? So the system utilizes the webcam, which is the Intex IT305BC, to capture images of products on the conveyor belt, providing visual data for color inspection. The image processing software, implemented in MATLAB with the image processing toolbox, analyzes these images using the RGB color space. Threshold values for specific colors are set to facilitate color detection. The proximity sensor detects the presence of products on the conveyor belt, sending signals to the microcontroller, which is at Mega 32, which in turn controls the conveyor belt and robotic arm movements. The conveyor belt, driven by the DC servo motor, transports products for inspection, while the robotic arm, equipped with servo motors, performs a sorting based on color. Interfacing components, including the MAX 232 IC, facilitate communication between the computer, microcontroller, actuators, and sensors. So this is the circuit diagram of the MAX 212 IC to the microcontroller. So it shows the MAX 212 IC to microcontroller. So in this figure too, which is the microcontroller to the actuators, which is the stepper motor and servo motor. So interconnects with the servo motor and servo motors based on the given description above. So there are many pins that the specifies in the microcontroller. So in microcontroller to servo motor, so it interconnects that Mega 32 and the servo motor. So this is the 3D model of the system, which is the 3D model of the entire system. So how do they form the data set? So the data set with the automatic sorting machine with machine vision is formed through a systematic process that involves capturing diverse images of products placed on the conveyor belt using the web camera, which is the Intex IT305BC. These images are meticulously labeled with the corresponding colors or categories to create a ground truth for the system. So manual labeling ensures accuracy in associating each image with the correct class, facilitating supervised learning. To enhance the dataset, various data augmentation techniques, such as the rotation and scaling, are applied to simulate the different real-world conditions. The dataset is then split into training and testing sets, with the former used to teach the image processing algorithm, the patterns and features associated with different colors. Balancing is crucial. Um, with the form used the image positively patterns and features associated with the colors. Balancing is crucial to prevent biases, ensuring each color or category is adequately represented. The organized dataset, stored in a structured format, serves as the foundation for training and evaluating the machine learning model's performance. Continuous improvement involves periodic updates to include the new samples and variations encountered during actual system operation, ensuring the model's effectiveness under revolving conditions. So how do they clean the data? So the article does not state the clean process of the data. So how do they process data? So the data processing in automatic sorting machine with machine vision involves multiple stages. Initially, when the product is in the conveyor belt, the sensor detects its presence and signals the microcontroller. This signal is then sent to the computer via serial interfacing. The image processing software, which is the MATLAB, commands the camera to capture an image. After capturing the image, the software processes it, generating signals based on the color requirements. These signals are sent back to the microcontroller, which in return controls the conveyor belt and robotic arm. The robotic arm picks up and places up the component according to its color, rejecting it if it doesn't match to the specified color. So what were their findings? So the findings emphasize the effectiveness of the machine vision, particularly in color-based identification and sorting processes. The application is not only limited to the one industry, but has diverse applications in areas such as the pharmaceuticals, agriculture, and automobile assembly. Additionally, the integration of the MATLAB for image processing and a microcontroller for motor control highlights the multidisciplinary nature of the solution. So, what are your takeaways on this paper review? So, the automatic sorting machine using machine vision technology is designed for high speed, accurate, the color-based inspection in industrial settings. It focuses on tasks like verification, sorting, and inspection of manufactured goods, employing components such as the sensors, microcontrollers, cameras, robot arms, and conveyor belts. The system utilizes MATLAB-based image processing in the RGB color space for effective color detection. So detailed interfacing between the components is outlined. So the system is presented as a current solution with potential for future enhancements, including the expanded sorting capabilities and defect detection. So that's all for my PIT reporting. So that's all, and thank you.